Before we get into the comparison of SN1 and SN2 reactions, I want to make one more note about SN1 reactions. SN1 reactions can have rearrangements because we have the carbocation intermediate. So you can have the hydride and methyl shifts. Just to give you an example, we have the following alkyl halide. So the first step would be formation of the carbocation. So bromine leaves and we have a primary carbocation. Well, if we have a methyl shift, now the methyl or hydride need to be adjacent or next to the positive charge. Okay, so this methyl group is next to the positive charge. We now have a tertiary carbocation. And so if we have the carbocation in a solvent, such as ethanol, it can act as a nucleophile. So here the solvent is the nucleophile. We do have an oxonium ion here that we deprotonate, and our final product is an ether. This is our product. Alright, so let's compare SN1 and SN2. Let's rewrite the rates. So this is for SN1, the rate for SN2. It has both the nucleophile and the substrate. So if we look at the effect of the nucleophile, because the nucleophile is not involved in SN1, the nucleophile strength is unimportant. We can have a weak nucleophile. For SN2, the nucleophile is involved in the rate, so strong nucleophiles are required. let's look at the effect of the substrate. Okay, in SN1, the rate determining step is formation of a carbocation. In SN2, we have both the nucleophile and substrate in the slow step, and we need to have access to the alpha carbon. So for SN1, tertiary is better than secondary. Okay. Primary and methyl do not react by SN1. Be aware that you can have a primary allylic that will go by SN1. For SN2, methyl is better than primary, which is better than secondary. Tertiary is unreactive. So the tertiary is going to be unreactive. And the tertiary is unreactive because there's too much hindrance. Alright, so if you see here, we have secondary written down for both SN1 and SN2. We're going to have to look at other things such as the nucleophile and the solvent to determine if it's SN1 or SN2. If we look at the solvent, in SN1 we form ions. You have a cation, which is the carbocation, and you have the negative leaving group, so you have an anion. So SN1, you need a good ionizing solvent, something that stabilizes ions. That would be a polar protic solvent. For SN2, we can have a polar aprotic. Solvent. If we look at kinetics, and I redraw the rates, so what you can see is that the rate here for SN1 is proportional to the concentration of substrate. You double the substrate, you double the rate. For SN2, we have both the nucleophile and the substrate. So if we double the nucleophile, we double the rate. If you double the substrate, you double the rate. Stereochemistry. With SN1, you get a mixture where you have retention of configuration and inversion if the carbon is chiral. For SN2, if the carbon is chiral, you have inversion. So that summarizes SN1 and SN2 reactions, and I'll give you some problems on how you decide which is favored.